The voltage follower circuit that we see here on the right is a special case of the non-inverting amplifier. You'll recall from before that in the non-inverting amplifier, V out was equal to V sub S times R1 over R2 plus 1. Now to go from the inverting amplifier, or from the non-inverting amplifier to the voltage follower, we're going to let R1 become 0, replace it with a short circuit, and we're going to let R2 effectively become infinite because we're going to open this up and just remove this branch. And that's what we've got over here. We've got the source voltage applied to the non-inverting terminal, and the output voltage is fed back directly to the inverting terminal with no resistance in it. Thus, R1 goes to 0, R2 goes to infinity, and we're left with then over here, V out is equal to 1 times V sub S. Or the output voltage is just what the input voltage is. You might well say, well, wow, great, we have the output voltage here being the same as the input voltage. What have we accomplished? Well, a couple of things. And the other name for a voltage follower, by the way, voltage follower is meant to describe the idea that the output just follows the input. But the other common name for a voltage follower is that it's a buffer amplifier. And that gives us a little bit of a hint as to what this is doing. Because the source is going directly into the non-inverting terminal of the amplifier, very little, in fact, in an ideal situation, the current going in is 0. So the source doesn't have to, this voltage source doesn't have to supply any current. That becomes particularly useful when our source, if we were to draw the Thevenin equivalent of the source, when the Thevenin equivalent resistance is large, such that, and the source voltage is small, such that even the small amount of current being drawn from the source causes a significant voltage drop across this large resistor. And if we didn't start out with very much voltage to begin with, what little voltage we have is lost as we start to draw current from the source to do something with it. So what this does is the amplifier here buffers the source, making it so that the source doesn't have to provide any current. The voltage here is measured. It's transferred across the virtual short to the output. And the output then is the voltage there. And we have an output current that is supplied not by the source, but rather by our power supplies, plus V and minus V. So if perhaps we were limited to microamps here, we would have on the order of milliamps, because even a realizable op-amp will be able to produce output currents on the order of 10 to, say, 50 milliamps, pretty standard values of current that an amplifier can provide before you start to see significant drooping of the output voltage. Yet another name for a buffer or voltage follower is a current gain amplifier. As you can see, no current in and then some finite current out. These kinds of amplifiers find a lot of application in control systems or in systems where there are physical properties that cause changes in either voltage or resistance. And we want to measure that change in voltage or resistance with a circuit that can then control that voltage or current or resistance change. We find that as in transducers. Transducers are electromechanical devices that take some physical properties such as pressure or voltage, pressure, acceleration, temperature, humidity, acidity, any type of device that will measure some physical property like that and then either create a voltage that's proportional to it or a current that's proportional to it, or change a resistance that is proportional to that physical quantity Very frequently, those kinds of transducers have large impedances, large output resistances, and relatively small source voltages. And before we can do anything with them, we have to buffer that source with a voltage follower or a buffer or a current gain amplifier to then give us enough current to drive the rest of the control circuit. In other classes, we'll talk about instrumentation amplifiers that are designed to accomplish that exact thing.